So in this video, guys, so I will show you how to use the web-based app on LB-SPR, or the length-based spawning potential ratio. So this is in continuation sa atong lab exercise number 3, and this is after you access the GeoGebra app. So to start with, so this is the website for the app, web-based app. So here you have the information about the LB-SPR. So to use this web-based app, so here are the commands. So here we have the instructions, the upload data tab, plot data, fit model, and examine result. So to start with this application, so we upload our data. So the data that I provided and uploaded in VSUEE. So we upload that data here and run for the analysis. So the data for this should be saved as CSV file, because if you save it as XLS or other file types, so it will not be read by the program or by the app, so it should be in CSV file. So this is the data that I posted in VSUE, so for Cellar or Matambaka. So you open it, and then so here it's already uploaded. So after you upload the data, so you go here in the flat data and fit model, and after that you click here absolute, because we have our absolute data, we have absolute data because we gather the data from the field. And the name of our species, so you type here Cellar, so Cellar Communicalmus, and the life history ratio, so this one, the MK ratio. Again, so we obtain this from the literatures here, for example here by Jose and Ingles and Daniel Poli, and the other one from this, the Pongo et al. So this one you can search this on the internet. So it's a compilation of the different parameters for fish species in Philippine waters. So in that uh, file, so you can find the mortality and the growth ratio. So for Cellar, so the computed MK ratio is 1.736, and the L infinity, also based on the preferences, is around 28.5 cm. So for 28.5 cm. So it's in cm again, guys, and the length at maturity. So this is based on GeoGebra. So the L50 based on GeoGebra is 16.82 cm, and the L95 is 18.72. So we already input the data. So again cm. So after that, you click here plot data to plot our histogram. So here we have our histogram data. So it shows basically the size distribution of the data that we entered here. So for Cellar, so this the data, you can download this by clicking this button, and we also have this figure here, the O drive. So it's the same as the one in GeoGebra. So it's the O drive for mature. So you can see here that the proportion for LN50 is around 16.82, which is the same sa GeoGebra. So after plotting the data, you click your fit model. So it will superimpose the curve for the size frequency. So it will add this curve, and for the maturity data, so what is added is the selectivity curve. So you can observe here that the selectivity curve is situated after the maturity, which means that at some point, most of the fish that is caught, ang mga matambakan na na-caught, are caught after spawning or after they have matured. So again, this one you can download this figures. So after fitting the model, so now we are ready to examine the result for the spawning potential ratio itself. So just click here the examine result tab. So just leave here the default, so you don't need to change anything here. So the explanation here for the SPR limit, so we have 0.2 or 20% and zero point 0.4 uh, which is 40%. So this is because 20 to 40% spawning potential ratio is considered as sustainable for the stocks. So below 20, so you can consider the stock as unsustainable. So above 20%, so the stocks are sustainable. So that's why we have here the SPR limit as zero point 0.2. So this is the output table for the SPR. So here in this column SPR, so it explains here that the data that we ran through the analysis, so the spawning potential ratio is only 10%. So it's also reflected here in the pie chart. So the estimated spawning potential ratio for cellar is only 10%. So this is well below 20%, which is the limit for the SPR. So it's not sustainable because it's less than 10%. So this 10% SPR, we can increase this if we manipulate our data. So the actual data, if we add plus 1 cm for each data point. So the purpose for that, because we want to know at which size that we will obtain this 20% spawning potential ratio. So we can rerun the data again. So for example here for cellar connectalmo. So in here, this is the original data, but here I copy the data, and instead of a long time, let me open the original data to compare. So this one, so this is the original data. This one here, 18. But here, because we added 1 cm per data point, so 18, 17, 17, so it become 19, 19, 18. So we add 1 cm for each. So all data point plus 1 cm. So the file name for this is here, plus 1 cm. So we are going to rerun the analysis one more time using this plus 1 cm data. So let's try if the spawning potential ratio increased, if we increased 1 cm, the catches if we increased 1 cm. So, okay, so to do that, so again here, upload data, browse. So instead of, so how to use, so here, so we use the plus 1. So it's uploaded, it's complete. So we plot the model, so the MK ratio is, it's the same. So 1.736, 28.5, 1150, 16.82, 18.72. So for the CM, so we plot the data. So same, you can download this data as well as this figure at maturity. So after that, you fit the model, and you can also download this data as well as this maturity and selectivity curve. So the same explanation applies as what I explained earlier. So after fitting the model, so here we want to examine the result. So as we can see, so at plus 1 cm, so the spawning potential ratio increased from 10% to 16%. So there is a 6% increase if we increase the sizes of our catch by 1 cm. So we have a 6% increase. So from 10, mahimong 16%. So if we want further to increase para mahimong 20, so maybe we can add plus 2 instead of plus 1 cm. So if you want to do that, so you just add plus 2 cm sa inyong original data and again rerun the analysis. So again, the spawning potential ratio, so this refers to the potential of the stock, spawning potential of the stock, kadtong wala pa na fish out sa fishery. So they are allowed to spawn. So for unfished stock, so fishing is absent. So the SPR is 100% because wala may fishing nga nahitabo. But for those areas the fishing exists, so which is the reality, not only in the Philippines but around the world. So the spawning potential range from 0 to 100. So it depends on the area. So it's area specific. So this SPR are now being used by NGOs and other government institutions as reference point for conserving fisheries resources. So that's it, guys. So I hope you can follow the instructions that I made here. Thank you.